Welcome to the Deep Dive. Today, we're talking about Isaac Newton, a truly massive figure in science.
Absolutely. The name itself just evokes gravity, motion, light, the foundations of physics, really.
It really does. The apple, maybe,
Yeah,
is what
yeah.
most people think of. But our goal today is to go a bit deeper than those sort of greatest hits.
Yeah, beyond the highlight reel.
Exactly. We want to explore the whole story.
Yeah,
Where he came from, those early years, right through to his later life, which was, well, pretty complex.
it certainly was. And full of things people might not expect beyond just the science we learn in school.
Right. We pulled together some really interesting material to kind of paint that fuller picture, not just listing achievements, but looking at the man, his interests, even the surprising stuff.
We'll look at how he got started. We'll dig into those huge breakthroughs, obviously, but also touch on things like, well, alchemy and his religious views.
Fascinating. Okay, so let's start at the beginning. Isaac Newton. He was born Christmas Day, 1642 on one calendar.
Or early January 43 on the Gregorian one we use now. A memorable date either way.
Definitely. But here's the thing that always gets me, this giant of science. He wasn't exactly a star student early on.
No, far from it. The records suggest he was, well, pretty bad at school, actually. Played truant, apparently near the bottom of his class.
It's almost unbelievable, isn't it? How does that kid become Newton? It makes you wonder about how we spot potential.
It really does, challenges those neat narratives. But even then, there were maybe little signs of curiosity. He copied out a Latin phrase book, a letter from some unpublished work.
So maybe not engaged by the lessons, but his mind was still working, seeking things out.
Seems like it. And then somehow he gets into Trinity College, Cambridge in 1661, but as a sizar?
Right, which was like a work-study thing. He had to serve other students to pay his way.
Yeah, exactly. Not a grand entrance. And Cambridge back then was still very much focused on Aristotle.
Ancient philosophy.
But Newton didn't just stick to the syllabus. No, thankfully. He was reading the modern thinkers too, Descartes, and crucially, the astronomers who were turning everything upside down. Copernicus, Galileo, Kepler.
So he's soaking up these revolutionary ideas,
hmm
and then pretty quickly, he starts having his own breakthroughs, right, in mathematics.
Amazingly quickly. By 1665, even before he'd properly finished his degree, he's working on the binomial theorem and the very beginnings of calculus. Just incredible.
Calculus, while still basically a student.
Yeah.
And then everything changes because of the plague.
Yeah, the Great Plague hits London, Cambridge shuts down, and Newton heads back home to Woolsthorpe.
And you think, okay, time off. But this period, maybe 2 years he was away, it was unbelievably productive for him.
Astonishingly so. People call them his anni mirabilis, his miracle years. He's developing calculus further, working on his ideas about light and optics, and yes, starting to really formulate his theory of gravitation.
All while stuck at home during a plague. It's mind-boggling. This kid who was bottom of the class.
It's an amazing story, and it shows, doesn't it, that genius doesn't always follow the expected path.
Clearly not. And despite that earlier record, when Cambridge reopens, he goes back and gets made a Fellow of Trinity in 1667. His work must have spoken for itself.
It must have. Which brings us neatly to those huge scientific contributions, the things he's most famous for.
Okay, let's tackle the big ones. The laws of motion. They're so fundamental, but maybe give us the quick version.
Sure. So the first law is inertia. Basically, an object just keeps doing what it's doing, staying still or moving steadily unless you push or pull it.
Right. Makes sense. Like a ball won't move unless you kick it.
Exactly. Or it won't stop rolling unless something stops it, like friction. Then the second law connects force, mass, and acceleration. EFMA.
Ah, the famous equation.
Yeah. It just means the harder you push something, force, the faster it speeds up, acceleration. But if it's heavier, more mass, you need more force to get the same acceleration.
Got it. More stuff, harder to move.
Mm-hmm.
And the third.
Action-reaction. For every action, there's an equal and opposite reaction. You push on a wall, the wall pushes back on you with the same force.
Okay. Like how rockets work. Pushing gas down, rocket goes up.
Precisely. Simple ideas, but they explain so much about how the physical world works.
Incredibly powerful. And then there's his work on light. Optics. Also completely revolutionary.
Oh, absolutely. His big thing was showing that ordinary white light isn't, well, white or pure. It's actually a mixture of all the different colors of the rainbow.
The prism experiment, right? Shining light through glass and getting the colors out.
That's the one. He proved the colors weren't created by the prism, they were separated by it. They were already in the white light to begin with. Each color bends just a little differently.
Which also explained why things have color, didn't it?
Yes. An object looks red because it absorbs the other colors and reflects the red light back to your eye. It was a total shift in understanding.
And this understanding about light, about how different colors bend differently, that led him to rethink telescopes.
It did. He realized the standard telescopes of the day, using lenses refracting telescopes, had an inherent problem. Because each color bends differently, they couldn't all focus at the exact same point. You get blurry edges, color fringing.
Chromatic aberration.
That's the term. So Newton thought, why not use mirrors instead? Mirrors reflect all colors of light at the same angle.
So he invented the reflecting telescope.
He did. Built a working model himself, showed it to the Royal Society in 1672, a huge improvement.
Genius and practical. But I gather these ideas, especially about light, they weren't instantly accepted.
Oh, not at all. He got into some pretty fierce arguments, especially with Robert Hooke. People questioned his experiments, his interpretations. It took years for his theories on light to become widely accepted.
Right. Science isn't always smooth sailing. Hooke comes up a lot in Newton's story, doesn't he? Often not in a good way.
We'll definitely circle back to Hooke. But yeah, Newton faced resistance. Didn't stop him, though. He kept working on optics, diffraction, polarization, all sorts of complex light phenomena.
Okay, so laws of motion, optics. And then there's the big one, gravity. We mentioned the plague years, but the full theory took longer, right?
It did. That story about the apple, while maybe illustrative, isn't quite the whole picture. He did start thinking about it in the 1660s, wondering if the force pulling the apple down was the same force keeping the moon in orbit.
Makes sense. So what was the holdup?
His initial calculations didn't quite match up. The data he had for, the Earth's size wasn't accurate enough, so things seemed off. He actually put the problem aside for a while.
Really? He just dropped it?
For a time, yes. According to his own accounts, he laid aside further thoughts of this matter. It wasn't this single eureka moment.
So what brought him back to it?
A correspondence with Robert Hooke, funnily enough, around 1679-80, they were discussing planetary motion, and it seems Hooke's ideas might have prodded Newton to revisit his own work.
Hooke again. Their relationship was complicated.
Very. But around the same time, better measurements of the Earth's radius became available. Newton plugs these new, more accurate numbers into his old equations. And suddenly, it worked. The discrepancy vanished. The force pulling the apple matched the force holding the moon. It all clicked into place, universal gravitation.
Wow. That must have been an incredible moment.
Yeah.
Years later, the pieces finally fit.
Absolutely. And then comes that famous encounter with Edmund Halley in 1684. Halley, the comet guy.
Right. What happened there?
Halley had been discussing orbits with Hooke and Christopher Wren. They suspected an inverse square law for gravity, but couldn't prove mathematically what shape orbit that would produce. So Halley goes to Cambridge, asks Newton directly, if gravity follows an inverse square law, what path does a planet take?
And Newton knew.
Instantly. An ellipse, he says. Halley was stunned. Apparently Newton had done the calculations years before but hadn't published them, maybe couldn't find the papers right then.
Classic Newton, keeping things close to his chest.
Seems so, but Halley's visit spurred him on. Newton then worked intensely for the next couple of years, writing it all up, the maths, the proofs, which became the Principia Mathematica.
One of the most important scientific books ever written, basically explaining the workings of the solar system.
And so much more. It laid the groundwork for classical physics, monumental stuff.
Absolutely. Now, we think of him in academia, but he had a whole other career later on, didn't he? At the Royal Mint.
Yes, quite a significant role. From 1696, Warden, then Master of the Mint. And this wasn't just, a ceremonial post. He threw himself into it.
What did that involve? Counting coins?
A bit more than that. He got deep into the science of it, metallurgy, refining techniques, standardizing the coinage to fight counterfeiters, which was a huge problem. He approached it with the same rigor as his physics.
The science of money, huh? Trying to bring order to it, like he did with the universe.
That seems to be the way he saw it. Combating corruption and chaos through reason and, good science. He was incredibly active, right up until his death.
Okay, so that covers let's say, the official story. Physics, maths, the mint. But you mentioned other less expected interests. Alchemy, for one.
Yes, this is something that often surprises people. Newton spent a huge amount of time on alchemy. Decades, really. Maybe 25 years, overlapping with when he was writing the Principia.
25 years. Doing what? Trying to make gold?
Well, not quite like the sort of cartoon alchemist. For Newton, it seems alchemy was much deeper. It was philosophical, maybe even spiritual. He wrote about it aiming to glorify God in his wonderful works, to teach a man how to live well.
So less about getting rich, more about understanding the fundamental nature of matter, maybe finding hidden secrets.
Exactly. He had a massive collection of alchemical books, 138 of them found in his library. He clearly took it very seriously. He believed in this idea of a prisca sapientia, an ancient wisdom about nature that had been lost and could perhaps be rediscovered through alchemy and interpreting old texts.
That ties into his scientific work too, maybe. Like he described gravity mathematically, but was he looking for the underlying cause in alchemy?
That's a strong possibility. He seemed to feel there had to be deeper principles, maybe active agents governing things. Alchemy might have been, for him, a way to investigate that hidden layer of reality.
It had such a different dimension to him. And this search for deeper meaning, it extended to religion too, right? His views were apparently quite unconventional.
Very much so. Publicly, he was Church of England, but privately, he held beliefs considered heretical at the time. He strongly questioned the doctrine of the Trinity, for instance. He wrote extensively on theology, analyzing biblical texts with the same intensity he applied to physics.
Applying his analytical mind to scripture. Did he publish this stuff?
Mostly kept it private during his lifetime. It was dangerous stuff. But he was also deeply fascinated by biblical prophecy. Spent ages trying to interpret the books of Daniel and Revelation.
Trying to predict the future.
In a way, he developed rules for interpretation and did make some predictions based on his calculations. Famously, he suggested the papacy might end around 2016 based on one interpretation.
2016? Well, okay. Didn't quite pan out that way.
No. Shows the limits of applying that kind of analysis to prophecy, perhaps. But it demonstrates how important these theological questions were to him, right alongside his science. Some of his works on chronology and prophecy were published after he died.
So, physics, alchemy, theology. It wasn't separate boxes for him, was it? It seems like one big quest for understanding everything.
It really looks that way. He was influenced by thinkers like Henry Moore, who also looked beyond purely mechanical explanations. For Newton, it all seemed connected in trying to grasp God's design for the universe.
Okay, we've seen the genius, the unexpected depths, but Newton wasn't always the easiest personality, was he? Let's talk about the rivalries. Robert Hooke looms large here.
Oh, yes. Their relationship was incredibly fraught. Bitter, really. You know that famous quote, "If I have seen further, it is by standing on the shoulders of giants."
Yeah, sounds humble, acknowledging predecessors.
Well, maybe. But many historians think, given his feud with Hooke, who was apparently a man of shorter stature, it might have been a deliberate, sarcastic jab. A way of diminishing Hooke while sounding noble.
Ouch. That puts a different spin on it. And Hooke was a significant scientist himself.
Hugely. Hooke made contributions in so many areas: microscopy, mechanics, architecture. He even gave Newton crucial insights about planetary motion related to central forces that were important for the Principia. But Newton rarely gave him proper credit.
That seems pretty unfair. There's even that rumor about Newton destroying Hooke's portrait at the Royal Society.
It's a persistent rumor. Hard to prove definitively, but it speaks volumes about the bad blood between them. Newton became president of the Royal Society the year Hooke died, and Hooke's only known portrait vanished around that time.
Yikes. And Hooke wasn't the only one he clashed with. There was the whole calculus dispute with Leibniz.
Another huge, nasty fight. Gottfried Wilhelm von Leibniz, a brilliant German mathematician and philosopher. Both Newton and Leibniz independently developed calculus around the same time.
So who was first?
Newton probably developed his method of fluxions earlier. But, true to form, he was secretive, didn't publish it widely for years. Leibniz developed his own version and, crucially, published it with a notation system that was much more practical and easier to use.
The notation we still use today, most
Exactly. But Newton and his supporters accused Leibniz of plagiarism. It became this huge, ugly, nationalistic battle between English and continental mathematicians.
And that actually hurt science.
Arguably, yes. British mathematics became somewhat isolated for a while, sticking to Newton's more cumbersome notation and geometric style, while mathematicians on the continent forged ahead using Leibniz's more powerful analytical methods. Newton's desire for priority might have backfired in that sense.
Wow. So the genius was undeniable, but the man himself? Complex. driven, brilliant, but also secretive, maybe vindictive at times.
Absolutely. You see that drive in other areas, too, like his attempt to derive Boyle's law for gases from first principles, imagining gas particles repelling each other. It shows his deep need to find the fundamental reasons why things work the way they do.
So reflecting on all this, Newton is just so much more than the gravity guy, isn't he?
So much more. A revolutionary scientist, yes, fundamentally changing physics and maths, but also deeply immersed in alchemy, theology, prophecy, involved in public affairs at the Mint, capable of intense intellectual focus and, well, intense personal animosity.
It's a reminder that these historical figures, even the ones we put on pedestals, were real, complicated people living in a very different intellectual world than ours.
Exactly. Understanding his alchemical and theological interests doesn't diminish his science. It gives us a richer, more complete picture of his mind and his time. He was searching for a total understanding of the cosmos, physical and maybe metaphysical.
So for you listening, the takeaway really is that Newton's story is this incredible tapestry. Scientific brilliance woven together with intense rivalries, deep spiritual searching, and these surprising deep dives into things like alchemy.
It challenges us to think about how different ways of knowing scientific, philosophical, theological could coexist and even intertwine in one extraordinary mind.
Definitely. So here's a final thought for you to chew on. How connected were these seemingly separate threads in Newton's own mind? Was the physics, the alchemy, the theology all part of one single grand project to decode the universe? And maybe, for him, God's plan. Something to think about. Thanks for joining us on this deep dive.